Good morning, friends. Welcome back to the class. I hope you all are safe at home and healthy too. Now, in this session 8, in the chapter Set Theory, as the last session, we are going to take the important sums as under the head Higher Order Thinking Skill questions, shortly known as HOTS. Now, in this session, we are going to discuss through two major category questions. One is to prove a given statement with the help of the properties of sets. The second is application based questions. So let's try to understand this session very carefully. To get the excellency in the set theory chapter, you need to watch this video without fail till the end, and if possible watch the same session twice, thrice, as many times as you require. So let's have a discussion on it. Right. Before start this session, you need to remember few important things. What are they? I'm just listing out. Just try to remember. What are the things you required? Right. See, the first part is if X is belongs to A union B, which implies that X is belongs to A or X is belongs to B. The first and the most important point is if X एक एलिमेंट A यूनियन B को बिलोंग करता है या तो वो एलिमेंट A में होगा या B में होगा. Second point, if X is belongs to A intersection B, which implies that X must be belongs to A and X also belongs to B, because this symbol stands for and compulsory, that is common element, and here union stands for or, either A or B. Similarly, third point is if X is belongs to A minus B, which implies that X is belongs to A and, or you can also say but, X is not belongs to B. Very carefully, need to remember, understand. If X is belongs to A minus B means element which are in A not in B. और ये भी बोल सकते हैं सिर्फ A में से हम B का एलिमेंट को रिमूव करते हैं, यानी कि अगर X एलिमेंट A में है तो वो B में नहीं. In the same sense, X is belongs to A but is not belongs to B. The fourth point is, it's very important, this result which we are going to use in multiple questions. A minus B can also written as A intersection B dash. ये बहुत ही rarely click होता है बच्चों को, but इसका use सबसे ज्यादा होगा. A minus B can written as A intersection B dash. You can understand the same with the help of Venn diagram. Okay, already it is being discussed with the last sessions, previous sessions. Now with the help of these four fundamental things, we are going to discuss few statements which we need to prove. Already this worksheet being shared with you. From that worksheet only, question number wise, I am mentioning here which questions I am discussing. So I would like to take the question number 1. There are several, first of all, you need to understand there are several ways to prove a given statement. Most probably we are using the properties of sets. It may be properties of union, it may be properties of intersection, it may be the properties of distribution of union over intersection, intersection over union. Sometimes we are using De Morgan's law. You know that De Morgan's law is what? Right? That is law of complements. So by using that previous knowledge, we are going to prove certain results, right? That is one of the things. Second way to prove any statement is the important definition you might have remembered, that if A is subset B and B is a subset of A, then we can say that A equal to B. This is one of the statement we have defined when we have studied about the subset concept. So if every element of A is in B and every element of B is in A, so ultimately that the sets are said to be equal. Vice versa. If sets are equal, then A is subset B, B is a subset of A. So to prove any two sets are equal, it is sufficient to prove A is a subset of B and B is a subset of A. Remember, to prove any two sets are equal or any two operations are equal, then just it is sufficient to prove that A is subset of B and B is subset of A. So if you are able to prove these two things, so ultimately you could say A is equal to B. Getting my point? So with the help of this definition of subset and some notations, we are going to discuss few important results. Let's have the question number 1 from the worksheet itself. What was the question? If question is if A union B is equal to A intersection B, then A is equal to B. A union B is equal to A intersection B, then the sets are said to be equal. So we are going to prove this statement by using some properties R with the help of this statement. So finally, first I am using this statement. To prove any two sets are equal, what is thing to be proved? A must be subset of B, B must be subset of A. So I am explaining the methodology to proceed with this type of questions. First I will prove A subset B, then I will prove B subset A, then by the definition I could say that A is equal to B. For that what I am taking. Let X is an element belongs to set A. X is an element belongs to set A. So ultimately this X also belongs to A union B. अगर सेट X A में है तो definitely A union B में भी वो count होगा, right? By definition. Then X also belongs to A intersection B. Reason. What is given? A union B is equal to A intersection B. अगर union में है तो definitely वो intersection में भी होगा by the given information. So if it is A belongs to A union B, it also belongs to A intersection B, which implies that X is belongs to B. अगर X दोनों में है तो इसका मतलब है कि X also belongs to B. So from this discussion, what I can say here, if X is belongs to A, I got the result as X also belongs to B. By definition, I can say therefore A is subset B. Are you getting? X is belongs to A से start किया और हमने approach किया X is belongs to B यानी A में है तो B में है मतलब A का सारा element B में है यानी कि A is a subset of B. This is number 1. Now in the same manner I will start with there is another element Y which is belongs to B से start करूँगा A पे खत्म करूँगा, right? So I am just erasing this part. Yeah. Now I am taking next one. Let there is another element Y which is belongs to set B I started with, which implies that Y is also belongs to A intersection B, sorry, A union B by definition. But A union B is already equal to A intersection B, which is given that hence it also belongs to intersection, which implies that Y is belongs to A. If Y belongs to B, it also belongs to A, which implies that B is a subset of A. Result number 2. Now, from result number 1 and 2, I can say A is equal to B. Hence, proved. Is it simple or not? Just think. What's the definition I have used? If A subset B, then B subset A, we can say A is equal to B. So I was using this definition to prove certain results. To prove any two sets are equal, I always use this statement. I will start this method like this. I will assume x is belongs to A, then I will prove x is also belongs to B. If I assume y is belongs to B, then I will prove y is also belongs to A. By this statement, I can say A is a subset of B, B is a subset of A, then A must be equal to B. So this the method which we are going to use to prove some more results, right? Let's have a discussion on that. I am keeping this main result, this result as it is. I am taking the next question. Right. Question number 2 from the worksheet itself. Question number 2. The first part. Show that if A subset B and B subset C, then A is a subset of C. Remember, ये बहुत ही इंटरेस्टिंग सम है. अगर A का सारा एलिमेंट B में है, B का सारा एलिमेंट C में है, तो डेफिनेटली A का सारा एलिमेंट C में होंगे. Now to prove the same thing, to prove A is a subset of C, so definitely I will take the element like X is an element which is belongs to A. Okay. So ultimately what I am saying, what I am going to prove, अगर A में है वो element तो C में भी होना चाहिए, then only we can able to prove. So I will start the assumption like let there is an element X belongs to the set A, so which implies that X is also belongs to B. Reason, A is a subset of B given. This is the reason why I can say A subset B means जो A में है वो B में भी होगा. Which also implies that X is belongs to C. Reason again that B is a subset of C, यानी B का सारा एलिमेंट C में है, जो D में है वो C में भी है, as B is a subset of C. So it is sufficient to say that A is a subset of C. बहुत ही छोटा प्रूफ है बट बहुत ही सिंपल है. देखिए आप x a में है तो b में भी है, b में हो तो c में भी हो गया by the given condition. तो ultimately x is belongs to a if it also belongs to c, then a is subset c, hence over. Now the reverse condition, second का second part है, if a is not the subset of b, b is not the subset of c, then A is not always subset of C. Okay, it's not always. We have to prove अगर ये दोनों condition हैं, जरूरी नहीं है कि A is not always subset of C. I am writing the question in a proper language and then we will discuss that second part. The second part was here. The second part. If A is not subset B, B is not subset C, then right? It's not always A is, then it's not always A is not subset C. जरूरी नहीं है कि अगर A B का हिस्सा ना हो, B C का हिस्सा ना हो, तो जरूरी नहीं कि वो A C का हिस्सा नहीं हो. So to show this type of statements, not means we have to prove this statement is false. Remember, to prove any statement false in mathematical context, we are using the unique and the best method, that is counter example method. Counter example means what? Counter example technique or method. So this method is basically used to prove the given statement is false. Remember, whenever you wanted to prove a statement is wrong, just you need to give a super suitable example where it can fail, that we called as counter example method. Okay, So let's try to understand how can I give an example for this. I have to take an example of A, B, C set, right, randomly, right. So first I have to take like 1, comma 2, comma 3, and B I'm taking like 1, comma 2, C, yeah, I can also take like 1, comma 2, comma 5, and then I can take like, right, 1, comma 2, comma 3, comma 4. So I have set an example in such a way that first my example satisfy the given two conditions. ये satisfy होना चाहिए. A is not a subset of B. How could I say A में 1 2 3 है but वो 3 B में नहीं है. So from these example what I can say here, first 3 is an element belongs to A, right, but 3 is not belongs to set B, which implies that A is not a subset of B. First condition is done, which is good. And similarly, B is not the subset of C because phi is an element is in B but not in C. So what I am writing here, phi is belongs to set B but phi is not belongs to set C, which implies that B is not a subset of C, which is also given condition. So my examples satisfying the given two condition. Now what I have to prove, it's not always true that key A is not subset C, but if you see here, every element of A is in C, hence A is belongs to C. So what I can say here, but therefore now, yeah, now X is element of A, which implies that X is also element of C, which implies that A is subset of C. So hence proved. What I have done in this statement is I have set an example to show this statement is not always true. Okay, so if A is not subset B, B is not subset C, it is not necessary that A is not a subset of C. So these two questions purposely I have set in the question number 2 itself so that you can compare both the statements. The first statement was if A is subset B, B subset C, then A subset C. But counter means like A is not subset B, B is not subset C, it is not necessary that A is not subset C. So to prove any statement false, I have to set an example. That technique is known as counter example technique, counter example method, right? Just like you have studied in 10th standard contradiction method, right? So that is what the different technique. Now this is a different technique. So wherever we want to prove false, we are using this technique. Remember. Now coming to the next question. Fine. Now coming to the next question. What is that? So I am directly coming to question number 3 in a sequence. Question number 3. Question number 3 was show that if A is a subset of B, then C minus B is a subset of C minus A. C minus B is a subset of C minus A. Shall I rub this one so that we can get a space to write the steps? Now, C minus B is a subset of C minus A. This we have to remember. Right? What is the condition? If A is the subset of B, then this is true. This we have to prove. Again saying if this set is a subset of this set, it means that if any element is belongs to C minus B, that also belongs to C minus A. This is what we have to prove. So it is sufficient to prove if X is an element, is belongs to this set, it also belongs to this. Enough? So that is what I am going to do. So I am taking, like, let there is an element X is belongs to the first set, that is C minus B. So if it is belongs to C minus B, it means that that element is in C but not in B. So that is I am going to write X is belongs to what we called as C, but X is not belongs to B. Am I right? By definition? But you can say here, if X is not in B, then definitely it is not in A. Reason, A B का हिस्सा है, A का सारा एलिमेंट किसमें है, B में है. अगर B में ही X ना हो तो A में कैसा हो सकता है? In that sense, I can write X is belongs to C, but if it is not in B, it's not also not in A. Reason is it's already given that A is a subset of B, which is given. So which implies that now I can comprise this to get C. Right. Now to compare this, what I can say is X is belongs to C but not in A, so I can write it as C minus A. Now if X is belongs to C minus B is also belongs to C minus A, which implies that C minus B is a subset of C minus A. Hence proved. Okay, so I think you have understood the concept very clearly. I have discussed the sequentially 1, 2 and 3. Right, now to move to the further question, right, just a second, I need to connect the battery charger here. Okay, sorry for the disturbance. Now let's continue the session. Right. Now I'm taking the next question to understand. Famous worksheet itself. I'm leaving question number 4 and 5 for you because already I have explained how to take a counter example. You need to set a counter example wherever it is required. So I'm coming to the directly question number 6, where I am taking some random questions to prove. Let us take, by using the properties of sets, I have to prove that R show that this is a common tag. A set A is equal to A intersection B union A minus B. This is one of the statements. Now, just look at this question. We know already that set A is nothing but, just try to understand through the Venn diagram. Now you can realize what is this operation means. This is universal set. This is set A and set B. So what I can say, this blue portion is basically representing only A, right? Which also termed as A minus B. So this is A minus B. And what is this common portion here, which I am shading with red color? This common portion is what? The A intersection B. So finally, if you observe the set A is basically what? The union of these two areas. So ultimately set A can be written as A intersection B union A minus B. So this, we know it is a fact. This is the result, standard result. Now we have to prove this statement with the help of properties. So to prove such a statements, I can take like LHS to prove RHS, just as usual we are doing in maths, RHS to prove LHS. So it is very easy to reduce the biggest thing to a smallest one. So that's why I am taking the RHS to prove LHS. Okay, fine. I am writing here. I am taking the RHS part, right hand side part. What is the right hand side we have? A intersection B union A minus B. So first of all, I am converting this difference into intersection language. Means A intersection B union, I can write this operation as A intersection B dash, as I told you in the beginning of the session. A minus B, wherever the difference is there, I will write it in the intersection language so that I can use the properties in easiest manner. Now, this can be reduced again. A intersection of B union B dash just by distributive property. What I am using here? Distributive property. You may also cross check whether it is correct written or not. Just A intersection B को आप distribute करिए, you will get the previous step. A intersection B union A intersection B dash. Nothing else. Next. A intersection. We know that B intersection B union B dash will give universal set. Right? Law of क्या? Complement. Law of complement. A union A dash is universal set. Set B और B dash मिलकर तो universal set ही बनेगा. So now the coming to the point, last point, A intersection union will give always A. Intersection में हमेशा छोटा set as a result होगा. Union में क्या होगा? बड़ा set as a result होगा. एक थोड़ा सा shortcut है याद रखना. So A intersection union universal set is always give set A only. So I got the result as left hand side. Hence proved. See, I started with right hand side, then I got the LHS part. Hence this one is over. Now in the same manner, I am going to take one more part of the sixth question to prove in the same manner wherever the difference is there. I will convert them into an intersection part by using the law of complement or definition of difference of sets. Then I will use a distributive property. Then I will use a law of complement. This is a general process to prove such statements. Now take the next question. I am just keeping this Venn diagram as it is. See how many ways they are just asking this. See the same question, the same figure that can be asked in many ways. What they are asking, like the second part. A union B minus A, which is equal to what? A union B. Now, how could you prove this? Again, the same way which I have told you that this difference is there. This difference is there. First, I need to convert them into intersection by definition. So, I am taking the left hand side portion. I am directly writing A union B intersection A dash. I can write this difference as B intersection A dash. Now I can use a distributive property over here. I am distributing union over intersection. So it would be written as A union B intersection A union A dash. Now you can simply say A union B intersection A union A dash. A union A dash is what? Universal set. Right? So ultimately now you can take the intersection of A union B and the universal set. So A union B is always a part of universal set. Hence, their intersection would be a union B only. I got the RHS part. So simple, no? Simply, you need to understand the one single Venn diagram and the distributive property. Nothing else. Just to use that previous knowledge to prove this type of statement. It's so simple, so thrilling also. Fine. Coming to the next one, I am taking some more questions from the same sixth question. See. I am taking now the question which is the seventh part. Question number 6, seventh part. A minus B, which is equal to A intersection B. Again the same, to prove the difference must be converted into intersection language. तो याद रखिएगा मैं जो स्टेटमेंट बार बार यूज कर रहा हूं वो है ये पहले a माइनस b को मैं कैसे लिख रहा हूं a intersection b dash because the definition is same. So I'm just considering this as a single set first. Otherwise you may convert this and then come into this side. So a minus, this can be written as what? A intersection b dash. Now again it is a minus b form. So again I can write it as a intersection b dash. Getting point? इसमें पूरा b सेट मान लेता हूं तो a minus b फॉर्म में है तो इसको मैं लिख सकता हूं a intersection b dash. Now here I can use the De Morgan's law, which I am going to use De Morgan's law. Clear? So De Morgan's law says what? A intersection b whole dash is equal to a dash union b dash. So in this way I am going to elaborate this first. So a intersection, I am just elaborating this with the help of De Morgan's law. It can be written as a dash union b dash the whole dash. And then we know that complement of complement is a set itself. A dash whole dash the set itself. The law of complement says. So ultimately in the next section b dash whole dash becomes only b. Getting my point? Set b itself. Then distribute this intersection over union. So a intersection a dash union a intersection b. Getting? So ultimately just imagine a intersection a dash is just a null set. There is no common element between a set and its complement. Hence union what left? A intersection b. Now null set has no effect in the union case, so by combining these two sets what you will get? Only A intersection B. This is RHS. It's so simple. So just by taking left hand side, by converting the difference into complement, then by using the De Morgan's law, then by using the complement's law, like this distributive property. So the previous knowledge only I am using to prove such type of results. You may try it for the next remaining sums in the question number 6. Now I am moving to a different type of questions, right, where you need a small things to analyze the question. For that I am taking a specific questions again from the worksheet itself. Right. What I am taking. Yeah. See. Question number. Now see what is that? Question number from the worksheet itself. I am taking here question number 7 to 12. 7 to 12 all are related to power set. You know the definition of power set? So related to power set, how can you deal with power set? So you already know that power set is denoted by P of A, right? If as well as you also know that if number of element in a given set is, let us say there are some m elements, then ultimately it has 2 to the power of m number of subsets. Am I right? So if you write all the subsets in a set, that is a collection of all subset is known as what? Power set. Hence, the number of power set is also equal to what? 2 to the power of m, because all these subset become the element of power set. So by using this preliminary knowledge of power set, the definition and all, we are going to prove certain things which are very important. So in question, I am taking the question number 7 here. Question number 7, that if P of A is equal to P of B, which implies that A equal to B. The interesting result again it is, power set of two given sets are equal, then set must be equal. It can also prove vice versa, right? It's very important result. Now how we can prove this? Again saying, to prove any two sets are equal, it is sufficient to prove that A is a subset of B and B is a subset of A, right? So I am going to take that only. I am taking that one first. X is an element, let S belongs to set A. So ultimately, set X becomes the subset of A. If X is an element of A, then set X would be a subset of A. Then ultimately what we can say, set X is belongs to power set of A. अगर ये set A का subset है तो power set of A का element बन जाएगा by definition. But P of A is already equal to P of B, so I can say set X is belongs to P of B. So which also means that set X is a subset of set B. यहाँ मैंने P of A को P of B से रीजन है क्योंकि P of A P of B इक्वल है, ये ऑलरेडी गिवन है, इसलिए मैंने यहाँ चेंज किया. तो इसका बाय डेफिनेशन ये होता है कि set X is a subset of B, which implies that X is an element belongs to B. So it is now sufficient to speak X is belongs to A is also belongs to B, which implies that A is a subset of B. Result number 1. In similar manner, I am going to take Y is an element belongs to B, then I will prove it also belongs to A. Then I can say that B is a subset of A. For that, I am assuming that the second part, Y, let another element Y is belongs to B. I will start with B, I will end with A, which implies that set Y is a subset of B, which also implies that set Y is belongs to power set of B, which implies that set Y is belongs to P of A also, because these two are equal as given, which is given. Then set Y is a subset of A. It means that Y is an element belongs to A, which implies if Y belongs to B is also belongs to A, therefore B is subset of A, right? So this is result number 2. Now from 1 and 2, what I can say? A is equal to B. Because A subset B, B subset A, so definitely A is equal to B. So this is related to power set. Remember, if P of A is equal to P of B, then A must be equal to B. Vice versa, you can prove. If sets are equal, then power sets are equal. If power sets are equal, then sets are equal. It's very important result related to power set. Now let's take the second question related to the same power set. Right? See, what is that? Now, now the question is, prove that or show that, prove that P of A intersection B is also equal to P of A intersection P of B. What I have to prove? P of A intersection B is equal to P of A intersection P of B. It means what? इसका मतलब क्या होता है? These two sets are equal forever, right? So to prove again two sets are equal, it is sufficient to prove that if an element is belongs to this set, is also belongs to this set, right? So again the same method I am going to take. Let there is an element x belongs to this set, right? So it is now अगर x इसमें है तो x इसमें भी होगा, पहले ये प्रूफ करूंगा, फिर मैं यहाँ लूंगा अगर y इसमें है तो y इसमें भी है। इस तरीके से मैं दो ऑपरेशन को इक्वल प्रूफ करने जा रहा हूँ। So for that what I am taking here, if x is belongs to this, so what does it mean? That x is an element is belongs to power set, right? So x that becomes what? A subset of A intersection B. अगर ये इसका एलिमेंट है तो A intersection B का सबसेट होगा। It means that कि okay, just to understand, I am taking this capital X, capital X because it's a sub. Always belongs to that. Capital X belongs to P of A, sorry, power set of A intersection B. Then that capital X set is a subset of A intersection B. So ultimately, what I can say here, X is belongs to A intersection B. So why I am writing capital X and small x? Capital X is a set having an element X. So this is my assumption in my mind. अगर x एक एलिमेंट है जो कैपिटल X का हिस्सा है, या x is a set which having the element X. In this sense, अगर कैपिटल X इस पावर सेट का एलिमेंट है तो A इंटरसेक्शन B का वो सबसेट होगा। अगर ये सबसेट है तो अल्टीमेटली जो x एलिमेंट होगा वो दोनों के अंदर होगा, which implies that x is belongs to A and x is belongs to B. So ultimately again I am coming to reverse order. Capital X would be a subset of A and capital X would be a subset of B. Hence, capital X belongs to P of A and capital X is belongs to P of B. So now I can speak here, capital X is belongs to P of A intersection P of B. This is reason number 1. So what I can speak here, that if X is belongs to power set of A intersection B, it also belongs to P of A intersection P of B, which results that power set of A intersection B is a subset of P of A intersection P of B. This is half part done. I have proved that this set is a subset of this. Now similarly, just reverse these all the steps. यहाँ से start करिए, उल्टा बोलना शुरू करिए, तो ultimately you will arrive this step. If y is an element belongs to this, then ultimately it also belongs to this. I am leaving this second part for you as a homework. Please do practice in a reverse order. You will get that this is a subset of this. Hence, you can say these two operations are equal. Now, coming to the next and the most important point. Right. So the important point is the power set of any set, power set of any given set never be equal to null set, because if it is a null set, then also power set has one element as a subset. Hence, power set of any set cannot be equal to null set, which also implies that the number of elements in power set A never be equal to 0. Ultimately, I mean to say that number of power set of A is always ग्रेटर देन और इक्वल टू 1। मिनिमम एक एलिमेंट होगा या एक से ज्यादा एलिमेंट होता है पावर सेट। पावर सेट फॉर अ गिवन सेट के लिए कभी नल सेट नहीं होगा। दिस इज मोस्ट इंपॉर्टेंट रिजल्ट। इसको मैंने एज अ क्वेश्चन भी फ्रेम किया है। यू कैन आल्सो स्टेट दिस सॉल्यूशन फॉर द रीजन। ओके, नाउ कमिंग टू द नेक्स्ट वन, सम क्रिटिकल सम्स है जहां आपको थोड़ा सा कैलकुलेशन का स्मार्टनेस की रिक्वायरमेंट है। उसके लिए मैं एक क्वेश्चन नंबर ले रहा हूं वर्कशीट के अंदर से। देखिए, अब ये पावर सेट को यहाँ कंसेप्ट खत्म होता है। आप रिमेनिंग क्वेश्चंस पावर सेट के रिलेटेड आप ट्राई करेंगे। I am taking now the question where you required my assistance. See, question number 18 की बात हो रही है। Question number 18 में what I have used, there are two finite sets having the m elements and n. There are two finite sets, means number of A is m and number of B set is n. Right? They are saying that there are two sets A and B having the finite set elements m and n, and the number of subsets of the first set is 1, 1, 2 more than the number of subsets of the second set. And what they are saying, number of subsets of, if set A has m elements, the number of subset of this element would be 2 power n. This is what number of subsets. Number of subsets. Given that which is what 1, 1, 2 more than the number of subsets of the second set. Okay, these two things are given to us. So what we need to find? Find the value of m and value of n. कितने elements होंगे? What is the condition given? There are two finite sets having the m and n element, also satisfying that the relation between their number of subsets are given. Number of subsets of the first set is 1, 1, 2 more than the number of subsets of the second set. So 2 to the power of m is equal to 1, 1, 2 plus 2 to the power of m. Now you need to calculate the value of m and n. It's sometimes the answers may strike directly by just thinking orally, but sometimes it's not. So for that, you need to have a perfect method to calculate m and n without thinking in that random way. Okay. For that, I'm just simplifying this equation in smart way. How? See, 2 to the power of m minus 2 to the power of n is equal to 112 as given statement. I'm just getting the factors of 112 by taking the prime factorization method. So 2 5s are 2 6s are, then 2 2s are 2 8s are, 2 14s are, am I right? And then 2 7s are, 7 1s are, you can say. So here I can write 2 to the power of m minus 2 to the power of n. This 112 can written as 2 to the power of 4 into 7. Now what is the purpose of writing this prime factorization? There is a purpose. See, 2 to the power of 4. Now this 7 can written as 2 cube minus 1. 8 minus 1. Sir, why we are writing in this way? Now you can see the next step, how these two are get connected. If I take 2 to the power of n as a common factor, मैं 2 to the power of n को common निकाल रहा हूँ left hand side से, तो ultimately this would be what? m minus n minus 1. Right? So I hope you have understood this step. मैं 2 to the power of n common निकाला, इसका मतलब है मैं 2 to the power of n से multiply भी किया और divide भी किया, इससे ही मिला, is equal to what? 2 to the power of 4 into 2 cube minus 1. Now just compare these two factors on both the sides. This 2 to the power of n is compared to this and this factor is compared to this. So if I compared on both the sides, 2 to the power of n is equal to 2 to the power of 4, which implies that n must be equal to 4. Similarly, if I compare other two parts, 2 to the power of m minus n minus 1 is equal to 2 cube minus 1. So minus 1 get cancelled, which implies that 2 to the power of m minus n is equal to 2 cube, which also implies that m minus n is equal to 3, but n already equal to 4, so I can substitute 4 here. So ultimately m would be 7. So I got the answer. N is 4, m is 7. So this is just an art of calculations, right? Just by simplifying this statement. Remember, it's so important and fully logical question. Coming to the next one. Now, coming to the application based questions, right? Where see, remember कि क्या हम लोग कर रहे हैं, देखिए, the important thing is the question number 4, right? Question number 4 in the application based question, where you need to check whether the data is correct or not. To check any data is correct or not, just you might have the knowledge about the sets. आपको ये चीजें पता होना जरूरी है. देखिए, this is what universal set, this is set A and this is set B, and this is, you know, that this is A intersection B. So if you observe, the important point is what? A union B means these circles. So A union B is a part of universal set. Hence, number of A union B, matlab elements which are in A union B must be less than or equal to universal set. This is a learning one. Second learning point. This intersection part, you can see this is a part of set A as well as a part of set B. Hence, number of A intersection B is always less than or equal to number of A, and this A intersection B is always less than or equal to number of B. So if you are able to understand this connection, कि which is a subset of which and hence which must be followed, अगर ये आपको दिमाग में है तो अब आप क्या बोल सकते हैं कि हम गिवन क्वेश्चन को चेक करेंगे कि whether the data is correct or not. So for that I am taking the question number 4. Information is given, just you need to check. I am taking directly the third part, where number of U is given as 1000 and number of A dash intersection B dash is 200. Now just see what I am going to calculate and how I can interpret whether this data is correct or not. Just you need to decide whether it is right or wrong information which is given. For that I need to take this one, which is given as number of A dash intersection B dash, which will be equal to 200 given. Now I can use a De Morgan's law here to interpret what is that A union B the whole dash, right? Getting my point? This would be what? A union B the whole dash, which is equal to 200. So A union B whole dash means it's simply this set A subtracted from universal set. So number of U minus number of A union B, which is equal to 200. I am just elaborating this operation step by step. But number of U is given, that 1000, right? So I can use this value here, 1000 minus number of A union B, which is equal to 200. Hence, by simplifying, number of A union B will be equal to what? 800. So now, just I need to check whether the union which I have obtained is 800 which is less than the universal set, what I can say, what I got here, number of A union B value is less than number of U. Hence, I can say yes, the given statement is true, correct. It means the given values are appropriate. So this is a way. Just we need to simplify certain notations and get some of the A union B value required are A intersection B. Only four notations we are having. U, A, B, union, intersection. To check whether the data is correct or not, you required four parameters. Or minimum three parameters. For that, union is already given. So either you are able to get union or you are able to get intersection. So to check whether the data is correct or not with the union set, we required A union B. So how we got A union B? By simplifying A dash intersection B dash set with the help of some De Morgan law, and then we are able to speak. So this is what the whether the data is correct or incorrect. Coming to the last question of today's session. I would say instead of explaining the question, why won't we have a just discussion on the terminology which we require to solve such type of word problems? See, just we need to understand the concept of three sets again, which I have already explained each and every formulas related to two sets as well as three sets in the session 7. But still, here I am taking this topic in short way. Within 2 minutes, we'll understand the concept. Now, there are terminology which we required to understand. What is mean by that? At least one set out of given three sets. At least one set means कम से कम एक से ज़्यादा. So which implies that it's simply number of either A or B or C. Remember, at least one, more than one set, more than one complement, more than one product. It means that they are talking about the A union B union C. So sometimes students are not getting the idea what actually they wanted to. They have to calculate because the question is asking in wording form. What at least one set, at least one person, at least one book, at least one product means that is simply you need to calculate number of A union B union C. Now the second is exactly what we called as two sets out of three sets. Exactly two sets out of three sets. It means that what simply they are talking about this area, my dear, this area. Yeah, absolutely. So how we got this? A intersection B, B intersection C, C intersection A में से ये part को आपको remove करना है 3 times. Simply from A intersection B plus B intersection C plus C intersection A minus 3 times of number of A intersection B intersection C. This is when they are asking exactly two sets out of three sets. Now the important is none of the three sets. तीनों नहीं है. None of the three sets. It means that neither A nor B nor C. यानी कि ये खाली स्पेस की रिक्वायरमेंट है. This remaining the blank space, the green portion which I am shading the green portion which is what we called as neither A nor B nor C. ये बाहर का portion. How we got this remaining portion? What is that? None of the three sets means neither A nor B nor C. ना A है ना B है ना C है. इस केस में हम क्या बोल रहे हैं? इसको किस तरीके से लिख रहे हैं? सिंपल है कि यूनिवर्सल सेट में से ये तीनों सर्कल को रिमूव करना है. It means that number of U minus number of A union B union C. This is the way to calculate that none of the three sets clear. And the last point is A and B but not C. Very very important. Most of the बच्चे यहाँ confuse होते हैं. A and B but not C. इसका मतलब है A B तो होना चाहिए, मतलब A B का इंटरसेक्शन तो होना ही चाहिए, बट A B की इंटरसेक्शन में कौन सी पार्ट नहीं होना, C का हिस्सा नहीं होना चाहिए. मींस A इंटरसेक्शन B में से मुझे C का हिस्सा हटाना है. दिस इज द मीनिंग. सो हाउ कैन आई राइट हियर A and B required and C not required. How to write an expression form? A and B required and C is not required. So which is not required means that is dash of success. Which implies that A intersection B minus number of A intersection B intersection C. This is from the Venn diagram. A B हमें चाहिए, A B हमें चाहिए, common portion is required, but उसमें से C का हिस्सा नहीं होना चाहिए. So how could I eliminate the C part? Just by subtracting the A intersection B intersection C. So if you understood this terminology, I will assure you that definitely you will be able to solve the each and every word problem in easiest manner. Okay, so whenever you struggle anywhere while solving the word problem, I would suggest go for the simple Venn diagram, a rough sketch, make a rough sketch, and then shade which part you need to calculate. Okay, so ultimately the formulas can come in your mind. Definitely, this is the practice which I have made. I have experienced it. Now I'm enjoying these questions. There is no hurdle at all. So I would say at the end of this session is just do practice and complete the HOTS, higher order thinking skill questions which I have shared you, which are very very important to improve your skill regarding the set theory apart from NCERT. Okay, so take care and stay healthy and stay home. And thank you all of you for watching me for so long and watching this session number 8. So keep watching the session, keep learning and keep growing. Thank you once again. Big thank you once again.